Hey, welcome! We're about to jump into a really big question. What is the language of thought? And I don't mean English or Spanish. I mean the fundamental code, the mathematical language the brain itself is using to process everything around you. So what language is your brain speaking right now? Let's try and figure that out.
We live in a world that is completely built on digital logic. Your phone, your laptop, the entire internet. It all boils down to a super simple binary system. Ones and zeros, on or off, true or false. And yeah, it's incredibly powerful, but is that really how we think? I mean, what's the code that's running inside our own heads?
Just think about it for a second. The logic in a computer is totally rigid. It's absolute. A switch is either on or it's off. There's no in-between. But our thinking, it just feels different, doesn't it? It's kind of messy, it depends on the context, and it almost always lives in these shades of gray. So what if the brain's logic isn't built on simple switches at all? What if it's something else entirely?
Okay, so here's our game plan for this journey. First, we'll dive into this idea of logic that uses shapes and arrows. Then, we're going to zoom out and see how that fits into a much bigger picture, a geometry of thought. We'll get into why this all matters, why it's about thinking beyond just binary. And finally, we're going to tackle that huge question: what actually is a thought?
So, if our brains aren't using ones and zeros, what are they using? Well, there's a growing number of scientists who think the answer isn't about code at all, it's about geometry. So let's check out their model, which is called vector logic.
So the big idea here is to completely forget about on-off switches. Instead, I want you to imagine true and false as two totally separate arrows, or as they're called in math, vectors, pointing in different directions. See, a vector has both direction and length, which makes it a much richer way to represent information than just a simple 1 or a 0.
And here's basically how it works, in 3 steps. First, you just define your arrows for true and false. Then, and this is the cool part, logical operations like and or, they aren't gates anymore, they're actions. Think of them like rotating or stretching or even flipping those arrows. These actions transform the input arrows and give you a brand new output arrow. Logic literally becomes a geometric transformation.
Now, this simple shift from just points to arrows has a totally mind-bending result. I mean, if true is one arrow and false is another, well, what about all the other possible arrows that could exist in between them? All of a sudden, you've got a whole spectrum of truth values. This gives us a real mathematical way to represent things like mostly true or kind of false, all those nuances our brains deal with so effortlessly.
And as cool as vector logic is, it's really not just some isolated one-off theory. Nope, it's actually part of a much bigger, grander idea, that our entire cognitive world, everything we think and feel, might actually be built on geometric principles.
Now, don't worry, you don't need to be an expert in any of these. Just notice the theme that keeps popping up. Conceptual spaces, for example, treats an idea like apple as a specific region on a high-dimensional map. Tensorbrain theory and neural algebra use some really advanced geometry and algebra to model how patterns of firing neurons can create memories and perceptions. They're all different ways of getting at the same fundamental idea, that there's a hidden mathematical and geometric structure to the way we think.
Okay, so this is all really fascinating theory, but what does it mean in the real world? Why should we care if our brain uses vectors instead of bits? Well, this is where the abstract science starts to get very real. When you put all this research together, it points to one really powerful hypothesis. Our brains are fundamentally vector processing devices. We don't just compute answers like a calculator, we are actually navigating a high-dimensional space of meaning. A thought isn't just a calculation, it's more like a trajectory, a path, through that space.
And look, this isn't just some abstract idea, it actually has real explanatory power. Research is showing that this vector-based model helps explain some of the very specific logical difficulties that we see in patients with schizophrenia. That's a huge sign that this model is really tapping into something real about our neural hardware.
And this all leads to a really fascinating distinction. The rigid, absolute true or false logic that powers all our computers, that's something we have to learn. You can think of it like a cultural technology we invented. But our brain's native logic, the one we're actually born with, that might be something else entirely, something way more fluid and geometric, built on this foundation of vectors.
So this whole journey, from ones and zeros all the way to vectors and geometric spaces, it brings us right back to where we started, but with a much deeper perspective. It forces us to ask again, but on a whole new level, what even is a thought? So let's end on a final, pretty provocative thought. If thinking really is a form of geometric transformation, if all of our concepts are just regions in some vast mathematical space, what does that imply? Could it be that our capacity for understanding is ultimately defined by the geometry of our own minds? It's a wild idea to think about, that the very structure of our thoughts could set the ultimate horizon for what we are capable of knowing. Thanks for watching.